Okay, guys, we're going to talk about one more way to solve systems. It's called determinants and Cramer's rule. We've already done determinants of a 2 by 2, so we know how to do that. And we're going to use some of that knowledge to expand and figure out how to do the determinant of a 3 by 3 by hand, not with the calculator. So a little notation first. When you see a capital D here like this, it simply means the coefficient matrix. So if I look at my example with A's, B's, C's, and D's over here, capital D would simply be our A, B, C, D that we're used to dealing with. Okay? Then if you see the next one, D sub X right here, then we're going to take the first column of D and replace it by our solutions R and S here. So there's my R and S. So if I'm trying to do D sub X, I know I'm going to run out of room here, so you guys do your best. It's going to be, if I replace the first row with R and S, it's going to be R and S, and then I keep my B and D the same. Okay? And then if I do the third one there, D sub Y, okay, same idea, except this one's going to be replace the second column with R and S. So D sub Y would then be, all right, the first column stays the same. The second column becomes that R and S. Okay, so whenever you see those three values, and we can also do D sub Z and W's and all that good stuff. Okay, Cramer's rule. Here's what it says. Let's see if I can make that a little bit bigger. And you guys have it in front of you, and this is a bit blurry, so it'd probably be better to look down at your own screen. Here's what we're doing here. If we want to solve for X, Y, and Z, now on this screen I use the same notation that your book is using. They're using X sub 1, X sub 2, X sub 3, but we could easily call that, sorry, that's not a 3, that's an N on the end, X, Y, Z, W, we call them all those different variables, but I just wanted to follow the notation that you're going to see in your book if you want to go back to it. So what we need to do, in the short sense, is we need to find the determinant. These bars, when you see these big bars like that around D, that means find the determinant of the coefficient matrix. So it's not absolute value, it's determinant in this case. I know it's confusing. So if I want to find X again, I want to find the determinant of my coefficient matrix. That's going to go on the bottom. See this right here? So you see this value stays the same whether we're solving for X or Y or Z or W or X sub n if we keep going forever. So that D in the bars means the determinant of the coefficient matrix. Okay, then on top, again, I know it's a little blurry, sorry about that, we're going to find the determinant of D sub X, D sub Y, D sub Z, depending on what we're doing, or D sub N. All right, now I know, a little bit much, but let's do an example. Let's just jump right in and see how we're going to do this. So an example using Cramer's rule. Here we go. First step, we have to jump in, and we've got to at least set up our coefficient matrix. So let's write that all together. It's going to be 6, 12, 4, 7. There's our determinant, or I keep saying determinant, excuse me. There's our coefficient matrix. And if we want to find the determinant of it, then we're going to go, all right, these guys times each other, so 42, minus these guys times each other, 48. Okay, so the determinant would be -6. And to use the same notation, that's going to be determinant of coefficient matrix. All right, so that value is going to go under each of the fractions that we're about to find. Okay, so now we need to find D sub X. And again, here's how we do that. D sub X is going to be the matrix where we replace the first row, or sorry, first column by 3320. That's these guys. And then the second column stays 12.7. Okay. And then if we do the same thing we did before, find the determinant of that matrix, the determinant of D sub X would then be -9. Okay. All right, let's go in. Let's do the same thing. D sub Y this time. All right, so this time we keep the same first column as our original coefficient matrix. And the second column then is going to be this 3320. Right, the R and the S if you want to talk about it like that. And then the determinant of that matrix, all right, again, it's not absolute value, those mean determinant, would be 2. I'm sorry, 12, negative 12. All right, you can calculate that on your own if you want to. All right, now, this new rule, Cramer's rule, here's what he says. He says I should be able to take the determinant of d sub x, okay, so that's 9, negative 9. Put it over the determinant of the coefficient matrix, okay, we found that to be negative 6. And that's what our x should be. We reduce it down always. X is 3/2. And I should be able to do it for y as well. Y equals, okay, determinant d sub y, so negative 12, over determinant of the coefficient matrix, y should be 2. All right. Now, just like every other section in this chapter, you got to write it as an ordered pair. So I'd write the answer as 3/2, comma, 2. All right, now we're going to talk about a 3x3. These get a little trickier, but just do your best. I'll do one example, start to finish, and then I'll have you try the one right below here. All right, first step for any of these. Let's write this guy as a matrix. Here we go. So negative 2, 0, 1. And we're just going to do the coefficients. We're not going to worry about the other ones now. Then we're going to go 1, 2, negative 1. And we're going to go 3, 5, 2. All right, here's the coefficient matrix. Now, if we want to find the determinant about it, we're going to do it by expanding the determinant by the first row. So here's the one I'm going to be looking at. Now, just to give you a heads up, you could do any row you want. Typically, we all want to do it the same way, some of us anyway, so we grab the first row. And I'll give you the very first step. When we start writing this out over here, it's going to be negative 2 is the first value. I write that out, times something. We're going to figure that out in just a minute. Okay, then we're going to do minus the next number, 0, times something. Then it's going to be a plus 1 times something. Now, it always goes in that order. You take the positive of whatever that first value is, and now I know a positive times a negative 2, it's still negative. Then you go negative for the next term and a positive. So when you're doing this step, it always goes like this. And there's a reason for that. We can talk about that in class, but that's always the setup here. All right, now, this gets a little confusing. It may even get a little messy on the screen, but I'll do my best here. If we want to figure out what goes in these parentheses, and again, this is how we find the determinant of a 3x3, we're going to look at the first value, this negative 2, and we're going to kind of either visually or actually mark out. See, I'm taking mine in green. Hopefully I can erase that in a minute. And then look at what's left here. We have here this little 2x2 guy down here. And we're going to find the determinant of that. So it would be 4 minus a negative 5 becomes plus. Okay, so there's the first part. Now I'm going to see, let's see how well this little eraser tool works. If I can just get rid of my green. Nope. Okay, hang on a second. I'm going to rewrite this whole first matrix now. I thought I could just do the green. All right, let's do that all over again. So the first matrix, negative 2, 0, 1. Sorry about this. 1, 2, negative 1, 3, 5, 2. Okay, now let's go back. Now if you look, so I've got my first value here, this 4 plus 5. Now if I take my 0 term, so here's my 0 term, and I mark off the column it's in as well as the row, I've got a 2 by 2. 1, 3, negative 1, 2. So if I find the determinant of what's left here, it's going to be 2 plus 3. All right, so we're kind of crossing out rows and columns, and at the same time, we're finding the determinant of the remaining 2 by 2. All right, so again, I know a little messy here. I'm going to try this one in purple. If I mark out the column and row of 1, here's the 2 by 2 guy I have left. So I'm going to say the determinant of it would be 5 minus 6. Okay, so then if I do all these calculations, I'm fairly certain you guys can handle that. Do all these calculations, negative 2 times 9, da, 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 da. The determinant of this matrix would then be negative 19. Okay, so here's my notation. Then if we follow the same thing we did with the front side, with a 2 by 2, if we want to find d sub x, what I do now is I replace the first column with this 2, 9, 22. Sorry, it's a messy 9. And then the other columns are going to remain the same. Okay. All right, then if I want to find d sub y, same idea. This time the second column is going to change. Everything else will remain the same. And the same goes for z. I've run out of space a bit. The same goes for d sub z would then be, so this time keep the first two columns the same and change the last column. All right, now, kind of a lengthy question we got going on here, but once we do all that, what you need to do next, so I've got my 3, d sub x, d sub y, d sub z, then you've got to do the process up here to find the determinant of each of those 3. Now, I'm going to save a little time. I did it ahead of time. So it would be 19 for the x, negative 95 for the y, and 0, oops, can't see that, and 0 for the z. And then what Cramer's rule says we should be able to do, we should be able to take for x, we should be able to take the x value, the determinant, over the determinant of the coefficient matrix. We should be able to take the determinant of the y over determinant of the coefficient matrix. And we should be able to take the determinant of the z over coefficient matrix determinant. So here is our ordered triplet according to Cramer's rule. All right, now it's up to you. You guys try that last one and bring it to class tomorrow.